So hello guys, welcome to my channel. Today I am going to discuss on AVL rotation technique, which is a part of data structure. So see, if the difference of the what is AVL rotation technique? If the difference of the height of the left subtree and the right subtree is more than 1, means the balance factor is, if it is more than 1, then we will have to perform then we have to balance the AVL tree using rotation technique. So see, there are 4 types of rotation technique. One is LL rotation, second is RR rotation, third is LR rotation, and fourth one is RL rotation. So we first comes to LL rotation. So see, this is if a tree becomes unbalanced when a node is inserted in the right subtree. So in a balanced AVL tree, if we insert one node in the right subtree, then it becomes unbalanced and we have to perform one LL rotation. Example, we are taking here 50, this will be 30, and this will be 60. Okay, so it is a balanced AVL tree. So here the balance factor is 0, and here it is 0, and here 1 minus of 1 is 0. Okay, so now we will do now insert 65. So after inserting 65, see 50, 30, 60, 65. So this is 0, balance factor is 0. This will be minus of 1, this will be 0, and this will be minus of 1. So this is also an AVL tree because balance factor is minus 1. This is a balanced AVL tree. So now we have to check next step. So see, so I am writing here clearly 50, 50 because there is not enough space, so I am writing it here. 65. See, so 0, minus 1, 0, and 1. Okay, so now inserting 80. So if we insert 80 now, 50, 30, 60, 65, and 80. So see, 0, minus 1, minus 2, and this will 1 minus of 3, minus 2. Okay, so this is the situation. So now this is an unbalanced AVL tree. So to make it balanced, we will perform left rotation. Okay, so see, if we perform left rotation, what will become? See, if this will, then 60 will come at the root position. Okay, 60 will come at the root position. So here we write 60 at first after performing left rotation. So left rotation means left to right. So 60 will come, and this 50 and 30 will come in the 50 and 30 will come in the left subtree position, and this 65 and 80 will come in the right subtree position. So after rotation, it will be, this will become, the final result is this. So see, 0 minus of 1, 0, 1. And here we have to check, after balancing we have to check the root balance factor of the root node, whether it is either 0 or 1 or minus 1 or plus 1. Okay, so we have to check here. So this is 0. Okay, so after it is 0, minus 1, 0 and plus 1, we have to check between this. So it is 0. So we can conclude that after left rotation the tree becomes balanced and it is an AVL tree. Okay, so here this is the left rotation. Now I am going to discuss on right rotation tree. So this is AVL right rotation. So AVL tree may become unbalanced if a node is inserted in the left tree. The tree needs a right rotation. So this tree will become, AVL tree will become unbalanced when we insert a node in the left tree portion. So for example, see 34, 26, 44, 40, 56. So this is a tree. So this is 0, this is 0, this will be 0, and this will be minus 1. So see, this is, there will be one, there will be one value in the left subtree portion and there will be two values. We will take, if there are more, so we will, when we are checking for the right subtree portion, then we will see in the right subtree this diagonally. Okay, so see, so this is minus 1. Okay, so this tree is balanced. This is an AVL tree. So now we are inserting 65, in the left tree. So see, what will it become? It become 34, 26, 44, 40, 56, and it will become 65. Okay, so see, so this is 0, this will be minus 1, this will be minus 1, this is 0, and this will be 1 and 1 minus of 3, that will become minus 2. The balance factor is minus 2, which is not an AVL tree. So we have to balance. So how we can balance? By performing right rotation. Okay, by performing right rotation means we have to make rotation from right to left, right to left. So see what will happen. 44 will be shifted here, so it will become 34, and 26, 44 will be shifted, and this 2 node will come in the left subtree portion. So see 34, 26, and this 40 will also be in the left subtree portion. So here it will add 40 here, and it will be, and this will come 56 and 60 will come in the right subtree portion. So here it will come. So see, this will be 0, this will be 0, this will be 0, this will be 0, this will be minus 1, and here it is 2, there are 2, and here it is 2, so 2 minus of 2, it will become 0. Okay, so now I will show you the RL rotation and LR rotation. Okay, so see, LR rotation, if a node, sorry, this will be a node, if a node is inserted in the right of the left subtree, then we will left subtree, then we have to perform one rotation, so that will be the LR rotation. To perform LR rotation, so see, for example, C A. Okay, now I am going to insert the node B. So if we insert in the right of the left subtree, this is very important, so guys, you have to remember this thing, right of the left subtree. So what is right of the left subtree? Left subtree, and this is right, so we have to insert here, right of the left subtree. Okay, so here it will, this is 0, this will be 1, and this will be 2. So we have to, in LR, always remember that we have to first perform RR rotation. There are 2 rotations will be there in LR and RL. So in LR's rotation we have to we have to perform this RR rotation, and next we have to perform LL rotation. Okay, so after the first so see, performing RR rotation, see, RR rotation means it will come, RR rotation means from right to left. So here what we will do, it will become C B A. Okay, after performing RR rotation, let's see, after performing RR rotation here, so it will come here and it will come here. So this is RR, right to left. So after performing RR rotation, it will become this. So see, 0 1 2. Okay, so 2, so we have to perform again another rotation, that is LL rotation. Second step, performing LL rotation. So see, so after LL rotation means left to right. So after performing left to, this will come here, this will come here, and this will come here. After B A C, here it will be 0, balance factor 0, and it will 1 minus of 1, so it will become 0. So this is all about LR rotation. Next, RL rotation. So see, this is AVL rotation if a node is inserted in the left of the right subtree. In LR rotation we know that right of the left subtree, and here in RL rotation, left of the right subtree. So see, left of the right subtree. So we have to perform then RL rotation. So same way, in RL rotation we will perform 2 rotation. First we perform LL rotation, which is from left to right, and next we will perform RR rotation, which is from which is from right to left. Okay, so see, we will take one example now. So example, see, example A C, and this is B. So here it is 0 1, and here it is minus 2. So first, so we are inserting B. Okay, so here, so after inserting B, I am skipping this step. So after inserting B, So this will be left of the right subtree, means left of the right subtree. So first we will perform L rotation, which is from left to right. So here B will here, and C will come here. So what will it become? A, C, D, after performing left rotation. So this is 0, this is -1, this is -2. Okay, so see, then perform right rotation. Okay, so if we perform right rotation, means right to left, so here it will come here, and here it will come, and here it will come. So C, A, B. So this is balanced. So balance factor is 0, and this is a AVL tree. This will become AVL tree. So if the balance factor is not between -1, 0 and 1, so we have to make balance by using rotation technique, which is LL rotation, RR rotation, LR rotation, and RL rotation. So remember one thing, in majority of the case, if the balance factor is -1, okay, if the balance factor is -1, then we will perform RR rotation. So you have to remember this point. If the balance factor is -1, then we will perform RR rotation. If it is +1, then it will be LL rotation. And if it is -2, then it will be RL rotation. And if the balance factor is +2, it will become LR rotation. So guys, we have to remember this technique. So when you are solving this type of tree, so you have a rotation technique. When you are going to solve the rotation, so you have to remember this table. Okay, so here I am ending this video now. I hope you like this video, and don't forget to share and subscribe and press the bell icon for latest update. On next video I will be discussing on examples of AVL tree. One example, so how you are going to form an AVL tree by using balance factor and rotation technique. Okay, so I am ending this video. Thank you. Bye.